NASA just keeps finding planets that should not exist. And the more we look, the stranger our universe becomes.
Worlds hotter than some stars, planets as fluffy as marshmallows, and even worlds that might orbit black holes themselves. Since the 1990s, missions like Kepler, TESS, and powerful ground-based telescopes have confirmed thousands of exoplanets. At first, these discoveries mostly fit our expectations. But then the data started to show worlds that broke all of our neat categories. Planets were supposed to follow simple rules. Small rocky worlds near the star, big gas giants far away. Reality had other plans.
Tonight we're exploring planets that seem to defy our logic, until we realize it's our logic that needs updating, not the universe.
We'll start with a world so hot it challenges our idea of what a planet even is.
On the dayside, the heat is so extreme that molecules literally get torn into individual atoms before drifting to the cooler night side.
It circles a massive, hot star in just about 1.5 Earth days. Hugging so...
Observations show the planet is likely shedding mass over time, an enormous world in the middle of a very long, very slow meltdown.
A planet with a temperature in the same ballpark as a low-mass star is not supposed to be comfortable in our mental picture of what a planet is.
Yet spectra from Kelt 9b match what physics predicts: atoms glowing at extreme temperatures under brutal stellar radiation.
Kelt 9b doesn't break physics. It just sits in a part of parameter space we never expected planets to occupy. This world reminds us that giant planets can survive in environments we once thought belonged only to stars.
From a planet that's too hot to feel real, to planets that are so fluffy they barely seem like planets at all.
TESS is all in its main Spitzer, making it one of the least dense planets.
Its density is so low that astronomers nicknamed it a cotton candy, or super puff world.
It orbits extremely close to its star, where intense heating and a small solid core may have inflated its atmosphere to ridiculous proportions.
Observations with space telescopes reveal a complex, extended atmosphere that is even escaping into space in giant plumes of gas. Worlds like this force us to refine our models of how gas giants grow and migrate, especially around smaller, cooler stars.
But if you want a world that really sounds like it defies logic, look at a marshmallow planet around a red dwarf.
It is the lowest dense giant known around a red dwarf.
It races around its star in just about 3.5 days, far closer than Mercury is to our Sun.
Flaplanets. One idea is that the star's composition delayed the planet's core growth. Another is that subtle orbital stretching heat
Cotton candy worlds and marshmallow worlds don't defy physics. They show that nature enjoys using the full range of what physics allows.
Some planets, though, feel less like desserts and more like nightmares.
HD 189733b looks like a beautiful blue world from afar, but that color comes from a blowtorched atmosphere.
Under extreme temperatures and winds that may reach thousands of kilometers per hour, silicate particles can condense and fall like shards of glass.
This is the world where it may literally rain glass sideways, a place where weather becomes a weapon.
On WASP 76b, another ultra-hot giant, metals like iron can vaporize on the...
Some models suggest those metals could condense and fall, turning the night side into a place of metal winds and possible iron rain.
These extreme atmospheres don't break our equations. They just apply them in ways that feel more like science fiction than science.
As weird as these worlds are, at least they still orbit normal stars. Our next idea challenges even that assumption. What if planets could orbit not a star, but a supermassive black hole? Theoretical work suggests that in the disks around giant black holes, dust and gas could clump together into new, massive planets, nicknamed planets.
There may be a safe zone in those disks where temperatures and densities allow planet formation, even in the presence of intense radiation.
Such worlds would take hundreds of thousands of years to complete an orbit, lit by the eerie glow of the disk rather than a familiar sun-like star.
Planets remain a theoretical idea for now, and no one has directly confirmed one, but the physics suggests they're possible.
They sit at the edge of what we call planet, stretching our definitions without violating the underlying laws.
From star-hot giants to marshmallow worlds and possible black hole planets, each of these objects seemed to defy logic when we first met them.
But step by step, astronomers have shown that none of them actually break physics. They only break our expectations.
Our intuition was built on one solar system. The data is built on thousands of others.
Every time a planet defies all logic, what really happens is that we add new lines to our diagrams and new terms to our models.
Simulations show that migration, heating, and disk chemistry can produce far more variety than we originally assumed.
The universe is not breaking our logic. It's inviting us to build a bigger, more flexible version of it.
Meanwhile, we're still searching for worlds that feel familiar enough to be homes rather than horror stories. For every impossible-seeming planet, there are quieter ones in habitable zones, where temperatures could allow liquid water. The extremes help us understand the rules, so we can better recognize the rare, fragile cases that might look a little like Earth. Every light curve, every spectrum from the world is a test of our theories about form.
Behind the wild artist's impressions are careful measurements. Tiny dips in starlight, slight...
Here on Universe Unlocked, we use those measurements as raw material for stories that stay honest to physics, but still feel cinematic.
A planet hotter than some stars, worlds lighter than cotton candy, storms of glass and metal, and planets that might orbit black holes.
They don't really defy all logic. They redefine what our logic has to be if we want it to match the universe we live in.
For the next generation, this new, weirder map of possible worlds will just be normal.
They'll grow up learning that planets can be marshmallows, blowtorches, or maybe even neighbors of black holes.
And maybe one of them will be the person who turns today's impossible planet into tomorrow's well-understood case study.
That's the core of science. We don't throw away the laws when something surprises us. We refine them until the surprises make sense.
Right now, in telescope archives and live streams of starlight, more impossible planets are waiting to be noticed.
New instruments and missions will push us to fainter stars, smaller planets, and even stranger combinations.
On Universe Unlocked, we'll keep following that frontier, whether it leads to rogue planets drifting in darkness or oceans under frozen shells.
Space is not obligated to make sense to us, but we are absolutely allowed to keep asking questions until it does.
Hotter than stars, softer than marshmallows, raining glass and metal, orbiting black holes.
All of them still obey the same core laws: gravity, quantum mechanics, thermodynamics. It's our mental shortcuts that had to give way.
From out here, our own world looks like just another exoplanet. One data point in a much bigger story.
Somewhere out there, there may be planets just as surprising, but also just as life-friendly as our own.
If you enjoyed this journey through the strangest worlds we know, you'll probably like our dives into ancient Earth and alien oceans too.
Subscribe to Universe Unlocked so you don't miss the next time a planet that defies all logic quietly becomes part of normal science.
Let us know in the comments which of these worlds you'd want to see a full, dedicated, deep dive episode on.
Kelt-9's burnout, marshmallow worlds, glass storms, or black hole planets. Your choice might decide our next mission.
Our job is to unlock that universe for you, one impossible planet at a time.
Somewhere in this vast map is a small world where we get to...
This is Universe Unlocked. Thank you for watching and for letting the universe surprise you.